This podcast is presented by NXAI, your partner for time series foundation models and physical AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seberg. Good morning, good afternoon, Robert, dear listeners, wherever you are.
Peter. We had some technical issues at the beginning of the recording. Now we try again. You are in sunny South Europe, I think. So would you share some AI news with us? It would be a pleasure.
I'm going to share some sunny AI news with you. I'm going to get into a little bit more detail, maybe later on where I am. I'm going to start with Figure AI robots. They ran 24 hours. I'm sure you've seen, all of us have seen. I think I saw it like 1,000 times. That's one of my topics. That's the actual topic almost. I don't know what it was. Officially, it was called successfully processing more than 100,000 parcels without any human intervention. Some kind of parcel sorting. Someone suggested they were repositioning the packages so they could be scanned. Now, what was most striking to me that everybody was sharing. Everybody seemed to be so impressed, and that's okay. But nobody was asking what was happening. What were they doing? I was asking all the time, what are they doing? And nobody was telling me. They were just moving parcels from left to right. Now, I'll come back to that in a moment. 2 weeks before, I was going to share, you were running off. You were in a hurry. A Figure AI at that time, so a couple of weeks back, had just retired their humanoids from BMW, right? And Camilla Mazzoleni, she looked into the numbers. She says they had been up for 50% at the time. At the moment, use case was helping build 30,000 BMWs, means they loaded sheet metal onto fixers. And what is very important is, and she said the three words, one task, one station, one line. And that's important. I'll come back to that in a moment. So then she compares the Figure humanoid to the industrial robots and the human workers, because that's what they have been doing, this type of work today, right? And it turns out that the humanoid is currently about 3 times the price of a robot that actually runs, so the industrial robot, or 2 times the cost of a human. Now, moving back to moving parcels from left to right, there was a competition between a Figure humanoid and a human, I believe, right? Now, while in the BMW case, the human to a robot is the correct baseline, because that's what today humans do. Or if it's a big site like BMW, I'm sure that's what industrial robots do, right? That's what they're there for. Now the parcel moving use case, I am convinced that, I don't know for how long, 15 to 20 years, that has been done fully automated. Companies like Bäumer, scanning parcels, automated data capture. Companies that by heart, Witron, doing the same for food warehouse automation, and many other companies. So I'm just not completely clear. Just to be sure, I'm not against per se humanoids in the factory, right? It's just that I do not see them working in brownfield environments. And they were built for humans and industrial robots. So I am very much looking forward to you.
I thought it has something to do with the barcode or something like this, to find the barcode on the parcel. Wasn't that the topic with the humanoid?
Yes, but that exists 10, 20 years, 360-degree scanning from all sides and from the bottom as well. You go over this line and there's a small blips in there, and you can. So that's my point. I think. Who was saying that? I think Jakub was also, was he sharing a piece on, I think that was about models. And I said it had to do with benchmarking. And it's always and it's that we're back in the 1990s when it was about processes. It's always about when you're going to be proud of something your solution is doing. I believe you need to be honest, and you need to compare to the baseline. So you need to compare your model, your LLM model, to a baseline way of doing maybe let's say machine learning or statistical, even if it's that you can't say I'm doing this wonderful great technology and it's perfect, because and I say this is what automated solutions have been doing since a long time. And that's why I said I don't understand what the humanoid is doing. The humanoid is moving packages from left to right. I'm not sure what they were doing.
Mm-hmm. What else do you have, Peter? Because I have something related to safety and robots. Maybe I go for. I need to explain a little, because every 3 months I get to host a meetup in Linz. And this time our guest was Dr. Tim Fischer from SICK. So from the company, safety sensor company. And our community knows him quite well because he's always joins our events, etc. So he spoke about safety and AI and how to bridge the gap between safety and AI. And then he made a comment that I found very interesting. And now please sit down. NVIDIA is heavily pushing into the safety market. Yeah. And Tim made a couple of comments, so I looked into it, and NVIDIA calls it outside-in safety. And they seem to be very actively involved in all the relevant committees. You know that when you have safety regulation, there are standards and committees, right? And
all the DINs and ISOs and whatever.
Yeah, exactly. And they are hiring a lot of people in the safety market. And this was very interesting. Tim told me that's a different approach than go via sensors, going via hardware infrastructure, so NVIDIA hardware infrastructure. And I'm really looking forward to get somebody out of the NVIDIA universe to talk about this topic, because this was very interesting for me that NVIDIA is now also actively going into the whole safety and functional safety market in the industrial sector. Very surprising for me.
Very interesting. Please do a podcast on it as well.
Yeah.
If we did when were we there? Our autumn activity, we were with SICK. And I think at that time, still the big topic was, as it had been for quite some time, that safety.
Detect human.
It's completely deterministic. And all the discussion was about how can a probability-based technology play a role in security safety. We're concentrating on safety in this case, right?
Exactly.
And I think we had a lot of discussion on that. And we did find out that, the guys from SICK said, yeah, there is potential. And we did talk a lot about exactly what you say, the ISOs and the DINs and where we're moving. If it's not that everybody and their mother are announcing that they work with NVIDIA, every day there's 10 big companies, right? And the NVIDIA stock keeps on moving and moving and moving. That's the one side. And if it's not some company announcing their cooperation with NVIDIA, it's NVIDIA, as you say, announcing or not announcing, but somebody else then saying that they are moving into fields which maybe we had not expected.
Exactly. I was very, very surprised. So okay. I really hope to get somebody from the NVIDIA team to talk about this topic, because I thought this is still a topic for all our manufacturing safety specialists, all since 15 years working on safety, and now NVIDIA is also entering this market.
But isn't a big development that we see as well? Maybe we'll discuss that again in the course of what we do today. But that the companies, as we suggested exactly 2 weeks ago, it was specifically OpenAI, but not only OpenAI, also Anthropic, I believe, that they had come up with their solution companies, right? So
integrators, yeah.
Right. So they say we now have this wonderful LLM solution for you. We keep on updating, and it's so awfully expensive, but it's not enough. So we're now going to need the highly trained humans that we already have, or we're going to get them out of the market. So we train them or we buy them. That's the other thing, right? And then we go to our customers and then we show our customers what they can do with it. And maybe that is one of those solutions. It feels, and I'm going to be talking now a little bit more about humans and work again. That's always the kind of a red line that goes through all of the things that we do. And I'm not sure it's the grab for the people that have a base until a good knowledge of doing something with the LLMs, in our case in the industrial environment, and then move to companies that still do not have the capabilities themselves. And maybe, I'm not sure, maybe not sure where it's coming from, but of course, NVIDIA has been moving with their simulation capabilities based on top of CUDA and what is the other thing called? Omniverse, is that right?
Omniverse, yeah.
So maybe it's an extension of their Omniverse capabilities, because if you are going to simulate your factory and you want to have it run, I'm just thinking of my architecture training, right? It's the same. The architect has been doing that for 2,000 years. And you put a couple of lines on a piece of paper, or what we did on a screen, and then you're going to build it. And that's, of course, what you're doing with the NVIDIA, with the Omniverse. Now, then the next step is you want to make sure that you can then simulate it in such a way that your factory floor is going to be safe, even if it's readily built and a year or two later, right? So, nevertheless, very much looking forward to if you're going to be doing that podcast.
Yeah, I will do that. Okay, what else do you have?
The second one is Andrew, my friend Andrew Wang. I have actually not been following him that much lately, because when I do, most of the time I disagree with him. So and that's okay. That's actually important that people can disagree.
So the love comes to an end.
Well, but I've been in disagreement with him lately many, many times. So
okay.
I'm just going to share two. I share one opinion, and Andrew, who is so much more important than I am in his market, nevertheless. So being Andrew, my problem is a little bit the lack of discussion. So it's maybe not even Andrew, because Andrew or some of the other high-profile AI guys, girls, and maybe a guy like Sepp who sits directly next to you, maybe those folks, those people do not always have the time, right? But sometimes I feel that Andrew is really playing the game by making statements such that you're not supposed to have a different opinion. That's my feeling. So I'm not on a personal crusade against Andrew. I did shortly consider introducing a hashtag in this direction, but I won't do that. But I'm going to share two topics that I have a different perspective from him. So the first one, that's a couple of weeks old, actually. I didn't come to share that before. He has a new course out. It's called Prompting for Everyone. And by the way, not to forget, I was one of in the meantime, I believe millions of people that did his machine learning class, right, 10 years ago. I mean, he's the number one on bringing technology to the masses of people. It wasn't he the Coursera guy that introduced it. So I did actually start on this course, and very soon I thought again, and that is my specific point here, is AI for humans, or are we humans still there for AI? And it's perfectly okay if we're in an evolutionary mode here, but I'm convinced that eventually, AI will ask humans if and what it needs for answering a request. Maybe until then, people can learn something from this course. I'm not going to have people go not to this course. You should go to this course if you can believe you can learn something. But I really expect you, listener, if you are an AI product developer, to have your AI tell me what it is that it needs from me, rather than me treating your AI as if it were dumb. So my point is, instead of me telling the AI, please do XYZ, oh, and by the way, I attach the following documents, I don't have to be that smart. I think the AI should tell me, oh, I'm very happy to answer your request. I can do a really good job if you give me access to A, B, and C. Or, in the meantime, I was really impressed here. This is not about Google against Andrew or whatever, I don't care. But it happens to be that I used Gemini, and Google came to me, and I had asked Gemini a couple of weeks back why I always have to go back to the theme block, so that it would know it could interact on that topic. And I think it had to do with data privacy. And now it's saying, if you want to, you don't need to go back anymore to the theme. If you want to, Gemini will know all the discussions you've had, and you can just pick it up from wherever. And I liked it. I liked it a lot. So in general, I would say, because that's what I want. And if you don't want, that's okay as well. If you don't want to have, technology, AI involved in your life, but if you have given AI access to your job, your home, your life, whatever, then I expect it to know where to go and find the relevant information rather than the other way around. So that was one topic. And if I talk about these things a little bit more higher level, not always specifically industrial AI, I expect you, listener, to apply it to your own environment, right? And I come to back later as well. And maybe there's a second one that I would like to share. It's about, and we talk about work. We talk about work so far. We talk about robots. And, do we want to see, I suggested, do we want to see a greenfield factory that is for humanoids? Well, yes, I'm interested in that. But at the same time, the next topic is that Andrew says there will be no AI job apocalypse, terrible word. I think he means a job apocalypse, right? Quote unquote, the story that AI will lead to massive unemployment is stoking unnecessary fear. AI, like any other technology, affect jobs, but telling overblown stories of large-scale unemployment is irresponsible and damaging. Let's put a stop to it. Now, there's this other guy, Patrick O'Callaghan, at least he's saying, well, as someone who has taken your awesome course, as I did, and millions of other people have, I loved it. I have to say, this is a pretty weak post, and I agree. Because, Andrew, he is the smart guy in AI, but he's not an economics guy. And I must say, I see so many examples. I'm not sure I'm going to go into the details of any of those. But last time it was around May 1, right? So I am actually in Italy. And I see all these posters around May 1, where we in Bavaria, where I live, where you live, put up these, May 1 polls, right? I would do a big party. Are you still there, Robert?
So, Peter, okay. And that's where our connection with Peter ends. He's in Thousand, Italy, enjoying the sea view and recording podcasts. So now we are moving on to the main part, I would say, with InPro, a joint venture between Volkswagen and Siemens. Peter, greetings to Thousand, Italy. Enjoy the sun, enjoy the sea. And now let's move to the main part. Bye-bye. Today I have two guests, Daniel Wolf and Florian Bohne. Daniel, welcome to the podcast.
Hello and good morning.
Good morning, good afternoon, good evening, wherever you are in the world, dear listeners. And the second guest is Florian. Florian, welcome to the podcast.
Yeah, hi, Robert. Thank you very much. It's a pleasure to be with you.
You both work at InPro, and the interesting thing about InPro is that it's a joint venture between Volkswagen and Siemens. You will have to explain that to us later. But first, please introduce yourself briefly to the listeners. Daniel, please start.
Yes, my name is Daniel Wolf. I work with InPro. I started my professional career as a mechanical engineer. I focus specifically on factory design and operations. That's a discipline where you look at the design, the engineering of the factory building, of the equipment, and all the infrastructure and the logistics, all these topics. So you quickly understand that a factory is a very complex system.
It's a complex ecosystem, yeah.
It's a very complex ecosystem.
Or a jungle, some call it.
Yes, it's an organism. Anyway, to understand this better, I already identified that simulation and digital tools are really a great help in this area. So I quickly moved into simulation, specifically material flow simulation. I was doing that for a couple of projects in the Volkswagen Wolfsburg plant, looking at line integrations of the Golf back then. And then I got into contact with InPro. And I was fascinated by the idea of InPro very quickly when I saw that InPro joins use cases, problems, applications from Volkswagen with digital solutions from different vendors and also Siemens. And then I contacted InPro. It was a match, and I've been here ever since. I moved from a project engineer role into team leadership. I've been doing that for some years, heading one of our development groups. The last years, I co-led our business unit for joint projects. And I've also been involved in industrial AI in the course of this topic.
Okay, and Florian, please introduce yourself.
Oh, yes. Yeah, my background is in numerical methods, finite element analysis and computer fluid dynamics. After the master's, I did my PhD at the Institute of Formic Technology and Machines in Hannover with Professor Behrens. And well, during my PhD, I already came into contact with the VW environment and the automotive industry, of course, because it's quite significant for the forming processes. And but during my PhD, I mainly looked into the field of numerical simulation and material characterization. And what we also did was back then already to look into the field of AI and if we can build up surrogate models in order to speed up the numerical simulations.
There's a lot going on when it comes to numerical simulation in the moment, right? When it comes to AI. Yeah.
Yes, that's definitely right. And having all these world models and ongoing, because in order to enable robots, it's a really fascinating field. And I would like to talk with you a lot about that, but I think there's not enough time because it's quite a fascinating topic.
Exactly. It's a new podcast. We need to do that again.
Yeah, you invite and we will be there. That's not a problem.
Yeah, perfect.
And when we looked into that, I think it was then back in 2018. Back then, all these methods and coding methods and so forth haven't been that strong. So it's much stronger right now, actually. So this is why you can also make a lot of much more progress. And then I did my PhD. I moved to Inpro. I worked for 2 years as a project lead. Then I was tasked to build up a group around the topic of next generation of computer-aided engineering methods. And then I looked much more closer into the AI because I already thought AI is really rich for methods. So when you have numerical methods, when you work into that topic, when you approach this topic of AI, it gives you much more opportunities to approach the problems more efficiently and with a different angle than before, because normally you do like rule-based program and so on. But more to that later. And then I went into this topic, and I think 2 years ago, we together in our project, we also started to address these topics and to make it really then the heart of the topic of the projects and the software. And that's what I'm going to talk about later. It's a lot about geometric deep learning and using it for the design of production processes.
Perfect. Normally, we do not speak a lot about the company, but let's talk briefly about the company because it's a joint venture by Siemens and Volkswagen. How did it come about? What is the focus of the company, Daniel?
Yes, that's a great question, and it's really interesting story. I was mentioning I was fascinated by the idea, and maybe as a fun fact or a little bit looking into history, you remember Berlin was a divided city in the Cold War era. A lot of industry that had been in Berlin before left the city due to that situation, and there was a time in the early 80s, in 1982, where politics and big companies together thought about how can we change that situation. And in 1982, in December.
So they called Deutschland AG, right? So everybody was involved together. Yeah, that was the spirit, right?
It was a different time, right? So a little bit different than today. So anyway, this politics and economic, big companies, they joined for innovation conferences, one of them being in December in Berlin, December 82. And there was an idea born between the board members of Siemens, of Daimler, BMW, to found a company that would address the need for innovation and for digitalization in factories and in manufacturing, and to build that specifically in Berlin. So that was an approach that today sounds natural in some ways to some of us. In many areas, we have a lot of industry collaborations today. Back then, it was kind of revolutionary, right? So to create a joint venture that would bring together big manufacturing and big technical providers to address innovation in manufacturing. And that's the birth story a little bit, very short, of Impro. 1983, Impro was founded and addressed topic that when you look into this, it's really interesting. They started to address topics that are still with us today. So it was about sensorics, it was about introduction of robots into the factory, robot programming, simulation, still with us today. And interestingly, development of expert systems. Expert systems is a certain branch of artificial intelligence. And if you look at that, essentially today we are still, in many areas, we have the same topics moving us in manufacturing, right? So that's really interesting.
But to be clear, Daniel, you do not work exclusively for Volkswagen, or am I wrong?
No, we are organized as a joint venture. That's the organization of the company. So we're an independent company, but we are very closely aligned with both these corporates. Today, we are a joint venture, as you mentioned, of Volkswagen and Siemens. Volkswagen for us is the partner that mostly challenges us with manufacturing problems and with the need to make production and manufacturing more efficient, more digital, bring it up to speed and save cost and time, both in engineering and operations. And Siemens, in many projects activities, brings a lot of technical background, expertise, hardware, and specifically also software. You know, the entire automation portfolio, S7 and all this TIA, but also the simulation tools. So this is a combination that we work in, and we are in between and both with them in an orchestration layer where we form the basis for cooperative projects, pre-competitive projects, where we look at the potential and the applications of digital approaches, technologies, also AI, specifically AI in the last years, of course, to bring it and how to bring it into production. And we do not only work as a think tank and a scouting company and exploration company, we also work as a development company. So we have development expertise in-house, both for software and AI. And we try to bring the solutions to the end, to the shop floor operations with Volkswagen and beyond.
So you scale solutions for your customers, right?
That's a target. The target is to provide value for manufacturing, for the real production, generate real business value. That's always the focus. So we have explorative freedom, of course, to find the approach, the right approach, how to generate value, but the target clearly is value, cost savings, time savings, and increased quality in manufacturing. That's where we are specifically looking at. And yeah, when it happens and when it makes sense, we integrate other customers and other companies as well, so we can work with other customers. We have projects and solutions running with other customers. That happens because the problems that Volkswagen has in manufacturing.
Do they have problems? Really?
Not problems, but challenges.
Challenges, yeah.
It's always a problem that arises in quality or in something. It's always a challenge for the engineer to improve it, obviously.
Exactly. We don't want to go into details when it comes to challenges, but when you talk to your customers, Florian, what are their current concerns or what are their current topics? Do they all just want agents on the shop floor, or they are also ready to use time series, simulation and AI and stuff like that? What are the current topics or concerns?
Robert, when I'm truthfully answering that, they're not interested in AI solely, they are interested in having the problem solved. And AI, I think, is a really big thing to do, and really gives you a lot of capabilities. So no engineer is going to tell you use AI in order to do something. They have the clear problems which they want to have solved. And now having all these methods like having large language models, also geometric deep learning, what I'm going to talk about later, or having agents, these are all give you capabilities to solve the problems. And this is what they're heading for and what they're striving to do.
But there's a lot going on, right? And how do you separate the good from the bad? What really makes sense and what doesn't make sense for the customer?
This is a really great question. And this is something where we go into discussion with the customer and where we ask, what is their problem? How can we solve the problem? And then every year I don't know, when we are planning the projects, there's a survival of the fittest process, so to say, and the ones which have a good, where we know that there's a good return of invest, and that all the colleagues are really involved, and that there is also the management is involved to solve a problem. These are the real good indicators for us then to, and of course seeing somehow a way to a solution, because just starting something and hoping that AI is going to solve it is not really a good approach. You should make sure that the path is clear with all the methods which there are, like having normal rule-based programming, having numerical simulation, but of course also AI. And this is, yeah. And when all that is clear, maybe Daniel, you add something how we do this survival of the fittest process and how we come to the projects. When this is clear and all the stakeholders from all participants then agree, then we start a project. Daniel, I think it's good when you give some more details if you can think of some.
Yeah, as mentioned, obviously, we are working on a specific area of cooperation between these large corporates, right? So there has to be a common interest in addressing a manufacturing challenge with a specific technology. So this is the scoping that we do very early on. And a very important fact, if not the most important one, is how do we see a real potential to build an innovative approach to generate real value in the manufacturing or in the engineering.
So you write business cases at the end.
The business case, exactly. We build business cases, we calculate them, and looking at technologies like AI, where many things are happening, and we have news every week coming out, new technologies to explore. We sometimes do not know exactly how we will address the challenge in the future. So we work in a fixed budget, flexible scope way of mode of working, mostly. We define the target, we define the value potential that we see, but we continue to iterate this in the course of our work, obviously, to be sure that we look at all the dimensions of the projects, of the later implementation, and also of the cooperation potential between the companies. And we do this continuously along the project. And if we identify that we are drifting off course, then we can correct quickly and we can also stop project.
Mm-hmm. That sounds like a crystal clear solution, a crystal clear process. But why is there, let's talk a little bit more common, why is there so de-illusionation? Why is there so much, we thought AI could solve more? So what is the problem for the German European industry, Florian, from your point of view?
Oh, that's a really great question.
Do we overestimate this topic, or
No.
is the process we are doing it the wrong way?
No, I think what is important is that where does it start? Does it start? It starts at like software companies, and here in Germany we do not have software companies really like in the United States. We have also a different market. It's not consumer based. It's more having industry. So when you have a consumer based market, you need other technologies in order to evaluate what kind of product is really like searched for. You have a lot of customers. You have to address that differently. When you are when you are in Germany and you have it like you're looking into the typical industries, you have like engineering problems like which have to do something like with rigid materials and solving these problems. This is different. So you of course you have a lot of data as well, but this data is coming from machines, and what you want to do to control the machine. So you have all these approaches already existing. There are a lot of in Germany, we are in Europe. We know how to do our stuff when it comes to the industry. So we know how to build a car. We know how to build also the best cars, I would say, and how to create that and how to make sure that they are safe and all that. Now, when AI comes to that, AI must bring a value for that. And all of these companies do a lot of programming, and programming is the one which large language models help right now a lot. They also speed up our working processes at Info. But at the industries, you do not program so much. You are much more like, you do much more stuff with physical stuff, like looking at a CAD, you do a simulation, you go into the shop floor and you try to solve problems. And these things, they must be, you need all the right technologies for that. And I think we are moving to that, to building up foundation models for these purposes. But this is what for us is really important to have then. And these large language models, of course, they support us tremendously when it comes to finding an answer and this stuff. But the impact's not directly as in software companies. And I think this is one of the big differences. And Daniel and I, this is what we are working on. We are working on introducing these new methods into the industry. And I think we are on a good path here. And I think this will come up. But in all the innovations, they take time. It takes time to fulfill it. There will be a failing. There will be problems. This is some challenges. This is normal. This is totally normal. It's frustrating, but it's normal, and we have to deal with it. And I think we are on a good path here in Germany. And this is something I want to say is we also have to fix all the other things. We have to have the energy in place. We have the data centers in place, and we have to make clear that this is going to be in place, then we can, when the technology of large language models and agentic working meets really the engineering work and makes it really fast, then we can also speed it up and scale it here in Germany even more when we have all this energy and data center in place. Yeah, this is, sorry for the long answer.
Can you please share 2 free projects? You already mentioned geometric deep learning. What are you doing in your daily business, Florian?
Yeah, I can do that.
Or you can share 2 by Florian, 1 by Daniel. Please, Florian, maybe you can start.
Yeah, perfect. Thank you very much. So when we are talking about geometric deep learning, we are using this for automatizing the design of production processes. So what is the design of a production process? So it's planning and engineering the production process. So it's really something which is then really enabling the process. And what do I understand under this is like defining the sequence operations, what kind of equipment is used, to do a layout, to do tooling, so to make everything then happen, so that when really you ramp up the production, that everything is in place, that everything works, and you need to lose time in order to fix a problem. So all that is what is happening beforehand, and is really, I think, at the heart of the industry, so to create these processes. And in the automotive industry, you have a special situation, I would say. It's not so special, but the geometry of the parts, the shape of the parts, or the assemblies, they do not change so much, actually, when you look at the body in white. So when you look at the fender, a trunk, a side panel, all these things are quite similar when it comes from one generation to another generation of a car, or even when you go from one car brand to another car brand, the fender, you will always make out what the fender is. So this is actually, you have all that already really similar, but every time you want to design a process, you start more or less from the beginning. Not totally, of course, but you start really early. And there's a lot of manual work processes going on. And what we are looking at is these working processes where you defining geometries or defining points, lines, or sections on geometries. And to be a little bit more concrete here, for example, clamping points. When you have a part which you want to measure, or a part which you want to weld, you have to clamp that part, and you must be really sure that it's properly clamped. And this is because you want to repetitively measure it, reduce warpage when it comes to the welding process. And well, already talking about welding, you have to define where are the weld points, where are the tack welds. Tack welds are the welds which you place before the real weld process in order to keep it together, the whole assembly. And you have to find, well, where do I do that? So where I put these tack welds, and you have to do that cautiously, because if you don't do that, you will have a lot of warpage in the geometry. So this is then affecting the warpage or the shape deviation of the whole part. We have inspection points. Where do you want to measure the part? How do you want to make sure that it's really in shape? And I could go on. Let's just shortly jump to injection molding processes, for example, defining the gates. All these are things where you have to define the geometry. And this is really manual processes, and these haven't been automatized. So this is really strange. You have a lot of data because you have done that many, many times, but you have not automatized it. However, when you look into the field of AI, robotics, this is your topic, Robert, there you have many methods which work with 3D objects. Also in autonomous driving, where you are processing a lot of geometric data. And this is why me and my team, we said, hey, let's have a look. Maybe these AI methods can really make a difference here. And so we went into the topic of geometric deep learning. And geometric deep learning, just shortly, it's able to, by the training process, you are able to identify geometric features on the geometry. And with help of, based on these features, there's a classification or segmentation done. So, but when you have that, it's a little bit difficult in the field of computer-aided engineering, because there you just have maybe 30 parts at your 30 different variances of a part. Because, well, you have a specific amount of cars you have produced, and you just have a specific amount of data. And this is maybe 30 or 50 parts, but this is not enough actually for normal standard AI methods, which normally start working when you have like 100 or 1,000 or something. And this is a challenge we discovered there. And also, when you're using this typical AI method, you have a big model and you push all the information into the weights or the parameters of the model, you cannot explain the results. But this is something really important to do, because you want to know, why is there a clamping point at a specific location, or why is there a weld point at a specific location? Just because it has been somewhere in the embedding space, this is not going to convince anyone who is going to, you have to sell that. These are challenges which are quite difficult and spicy. And also, when you have work on something new and you want to put it into the AI model, you need a training. And having a training process in a software is something which is difficult and challenged, because data must be properly prepared. You as a data engineer might not be able to look at it before it goes into the model, and it might somehow distort the model's result and so on. So this is something which is really difficult and challenges, but I think we are on the good path to solve these problems. And what we did is we looked at it and we took a little bit older approach, the case-based reasoning, which I think has been there already 10 years or 20 years. I'm not quite sure, maybe even more. And what you do there is, when you have a problem, you search and retrieve a similar case which you have in your database, and you're reusing the solution. You revise the solution, you adapt it to your purposes, and then you change the solution for improving then the algorithm. And we said, okay, I think we can use that. So what we are doing is, we have a legacy database, and we identify the most similar part. So having the most similar fender, or having the most similar side panel, we identify it. This is what we do with help of geometric deep learning. We then use the data, transfer this data to the new part, which the part in query. This is also something we do with geometric deep learning. And then what we do then is we use local rule-based checking. So we go into every point. We say, okay, we have some company rules which apply here. We have to take this and this into account, and we check that. And when we have done that, we have another layer, and then it becomes really interesting. It's checking it if it's necessary with help of a numerical simulation. So, for example, having a tolerance simulation and so on. So we combine here, so to say, these AI approaches with numerical simulation. So really, really exciting what we are doing.
The numerical simulation as a backbone, or as a second layer, or what is the idea there?
So this is a second layer of checking. So having a good guess, which comes from the database and from the transferring this knowledge from the most similar part to the part we have here, and then checking it and seeing, does it really hold up all the requirements? And if in case it does, we can go on and say, okay, this is a perfect clamp points or weld points or whatsoever. And the engineer can also look at it and say, okay, I'm convinced that's good. Let's keep working with it. And in case it doesn't, you can still have doing all the, I would say, normal stuff, then doing optimization and so on. But you already have a really good starting point. And this is a good starting point from delivered by the AI. However, Robert, when you now change the perspective, and when you change and you say, okay, I think this method we are using here is really nice also to build up digital twins to build up digital numerical methods or numerical simulation models, and using these for digital twins. And when you want to build a surrogate model, you need a lot of data. So you have to vary a lot the boundary condition, also the geometry, and there you need automatic processes which set up the model, because you cannot, when you want to build up a surrogate model, you cannot spend your time when it costs 2 weeks to set up a simulation model, which is not something too highly overestimating it. It can even take much more longer. So you need a lot of automatized methods in order to get the data, then to train in a surrogate model, and then to making this data available. And this is why also I think this method we are applying here is really interesting, because it can help you there to build up these simulation models with transferring this point and based on the all data.
But the next step is to use an AI simulation instead of a numerical simulation. This is the next step. Or am I wrong?
Yes, this is what I would like to do. This is when I can convince my customers. This is the way I would like to go, because this is this is the whole topic is really exciting, and we work really well together. But there must be the need. If we have good methods there, and if a normal simulation fulfills it, we do not have to change it, because normal simulation methods, they have been there for a long time. They have been established in a lengthy process. Many people trust in these. They have built up trust, and all the AI methods have to do the same. And that's not easy, because AI has always this myth of not being really precise or of making things up. This is something which is really toxic when you want to check something and be really sure that it's true. So there are a lot of skepticism, and this process of convincing the people is one thing we have to do a lot when we are doing projects.
I have one more question, because you mentioned welding and you mentioned injection molding, right? So how do you generalize now your solution through different domains? How do you do that?
Well, what you have to do is you have to look into the formats of the numerical simulation model. So there are established software companies and established software when it comes to the single process. So injection molding, you have a mold flow. When it comes to forming processes, you have autoform. And they are not alone, but these are the big players. These are like the ones which are mainly used. And and when you want now to use your methods with that, you need to know the data formats. You have to access these data formats. This is not easy because these are often closed formats, which you cannot access. And when you cannot access it, you cannot prepare the data for these simulation models. But in case you can do that, and you have like other simulation methods and other fields of simulation, for example, where you use Abacus or where you use LSDuino, which are really general purpose simulation models, there you have open standards of open formats, and then you can really work with these data formats. And when you can work with these data formats, you can prepare the data with help of other software tools. And these software tools then can be enriched with AI. And then you are able to access these and then to really to work with these. So this is the way to go.
Daniel, we haven't lost you, but Florian is so enthusiastic about the solution. Maybe you can go on with a second approach. But it's nice to hear that your employers are so enthusiastic when it comes to their work. Yeah.
I hope our listeners understand that we are an enthusiastic team, because technology and the challenges that we find, to bring that together is an exciting work. It is a privilege to be able to do that. Anyway, so yes, Florian is at a specific point in his work where basically the product world, the geometries and the equipment world of the factory join. The manufacturing concept that he mentioned that he's trying to generate or supporting with AI is in a critical stage where we define how an assembly is built from single parts. And I would like to jump into the other two directions. First, maybe the beginning of the entire engineering process. When you look at a car body assembly, it's typically in automotive monocoque shell manufacturing. It's made up out of a lot of metal, right? So mostly we have metal sheets that have to be joined together with different welding and joining techniques. And the first step always, and this is where we have successfully applied AI in the past, is to decide which types of metal can actually be joined. Of course, in industry and a company like Volkswagen has a lot of knowledge about this. This is not done right now newly. This is long-standing experience. So we thought about this particular niche or starting problem some years back. And when we started working with AI and actually have applied machine learning to this topic. So you must imagine when the engineer is designing his assembly, he has to choose different metal grades and thicknesses at some point. And industry is always providing new material grades and different thicknesses of sheets and so on. And so you have to decide about this. So you have to know, will I be able to join them? Will I be able to perform a welding process on it? And this is where we built an automated checking tool, basically a feasibility checker, you might call it, that evaluated the feasibility of joining two types of metal sheet together. That was a successful application of AI and specifically machine learning we built. Maybe to explain a little bit how it works. So from the experience of material testing, of engineering, our customer had a lot of data, of course, trial data, test data, specifying the type of material, the thickness, the physical and chemical properties, technical properties. And on the other hand, you have the information if a certain material combination can be welded and joined together. And these two information sets we joined together. We built trained a machine learning model on this and tested it and brought it to the internal production cloud of Volkswagen so everyone can use it. So this is where we bring in our software expertise to develop it in a way that it can be deployed to the internal platform and really everyone has access to it that needs to use it. And combine this model with a web UI, of course, where you can upload a specific material combination data and then get a result if this is a probable combination that can be welded well, or if there's maybe some technical challenges that would require some additional testing. And if you do this, you suddenly start automating a very basic process that has taken up a lot of effort and time before, and now is running automatically. You get an automatic recommendation. Of course, the human engineer has to validate and check these results if it sounds reasonable to him. But for the most part of cases, it works very well, and thus the economical benefit of is basically reducing the effort for physical testing that has to be done in the lab, right? So formerly you had to take the material sheets, really go to the lab or contract someone that operates a lab, make the test, wait for the test to be finished, gather the data, and so on. So it also delays the overall engineering process. It's not only about saving costs, it's also about getting faster.
I have one question, because from my experience, you talked about data, right? And normally the companies in the automotive industry, they have only good data. So they have not the bad data. So it's always a pity that you do not have enough bad data when it comes to material, when it comes to welding, when it comes to welding spots, etc. So how do you handle that?
In that specific case, we actually had data about non-feasible combinations.
Okay, great. You are lucky.
Yeah, we were lucky. I mean, of course, when you start such a project, you have to check, is the data available? Can I use it, pre-process it? That's a major part, again and again, also of our work. I mean, thinking about AI, it would be nice if you could develop AI the most part of the project, but in fact, we all know that there's a lot of pre-processing work to be done, organizational work around. So the pure development work is only a share. But yeah, I mean, as I mentioned, we try to identify problems, challenges, and use cases where we can actually work and generate a success. And in that case, we were lucky we had that data, we identified it, we could use it. And we have also encountered cases, of course, where it was not.
But you know the phenomenon, right? So the missing of bad data, right? Or bad results.
Yes, yeah. It is an issue, of course, yeah.
But we're also looking to synthetic data for that, Robert.
Yeah, that was my question. But it's tricky with synthetic data. Am I wrong?
It is tricky. We've made some activities and experiences with that, specifically in the area of quality assurance and quality testing. So generating visual defect data for different applications like press shop or functional services. And we found that given a certain amount of experimental test data, of real data available today, mostly you are able to generate very good synthetic data out of this. And if you combine the synthetic data with just a small amount of real defect data, then suddenly your data set and your models become much, much better. It's not in relation to each other, but just adding a small amount of real defect data to a synthetic data batch, we have found in our cases has really improved the quality of the prediction in the end, if a part or a feature is defect or not, at least for visual quality assurance topics. We've done a little bit of work on that. And I think now it's a technology that's really gaining traction and being distributed across industry more and more. So, of course, that's a very interesting topic.
And you can use Gen AI for this too, right?
Yes, that's a future direction, Gen AI, to operate these environments, these systems, and also to interact with data. Obviously, yeah, it's a very interesting approach. I mean, we are experimenting and developing also around co-pilots in several areas around simulation. That's a driving work stream, I would say, to integrate co-pilots and assistants into complex engineering and simulation systems. That's the first step.
Who is paying for that? Who is willing to pay for co-pilots? What should be the benefit to pay at the end? Because when you talk to everybody in the whole automation space, in the industrial automation space, everybody is working on automation, on co-pilots for engineering, etc., etc. But everybody tells me, oh, it's so difficult to sell to the customer because they say, oh, this is common technology. We know how to handle that. We are not willing to pay because I get it at Anthropic or Claude or ChatGPT for $15 a month. So is it really so difficult to sell it at the end?
That's a business and distribution question that's probably not fully to be answered yet in industry, I guess. It's a process of...
okay, so it's difficult.
Yeah, I guess it's an exploration process at the moment, how you market these functionalities, if they are part of the tools, if they are general purpose or specific purpose. I believe from the experience we have made with selected copilots, especially from Siemens in their tools, that a copilot can bring value, very specific value to users of the tools, not only explaining the tools and helping me to onboard, to learn and to study using that specific tool, which can be a huge hassle. I mean, look at the effort and the volume of documentation, of training that you have to go through if you want to use a standard simulation tool, like, for example, plant simulation from Siemens for automotive. I mean, you don't have just to learn plant simulation. You have to understand the modeling philosophy. You have to observe certain coding rules inside the tool. You have to observe specific automotive libraries. So all these aspects need to be considered, and they slow the onboarding time and they cost money in that course. So if you are able to build copilots that address specific domains and help me to solve my engineering task in a specific domain faster, I mean, there is tremendous value in copilots. But these would not be general purpose copilots like we see from Microsoft or, as you mentioned, from Anthropic and so on, that can help me code anything, but they need to be embedded and specifically intertwined with the simulation tool. If they understand my intention of modeling and my intention of analyzing a complex technical system, then they can help me much more than a general purpose agent or a copilot. But then they need to have some certain understanding of what I'm doing, both the process view and the system view. And this is where we are standing now in industry, or I think in this technology, where there's the challenge of building such things, right? Because this is not the first use case that you address when you build a general copilot, that you try to solve how to model, let's say, a clapping system for a cowboy assembly, right? So this is not the first use case you have on your list if you're Anthropic. So this is a road ahead, and yeah, maybe we can contribute to this in one or other topic.
Daniel, I have one more question to the management topic, right? So when I talk to industrial companies, they do a lot of POCs, and they say, oh, we do a POC in this and this and this. But at the end, when it comes to scaling, a lot of people are failing, or a lot of companies fail to scale now solutions through the whole company. How do you scale your solutions through a production plant by Volkswagen? How do you scale it? What is the magic behind the scaling?
Yeah, that's exactly the core issue that you address, and the most interesting part, and also the most challenging part of the work. Because, as you say, you start with a good idea, you see the potential, you start developing, you find good results in your first pilots, that you even apply it in the real plant. It runs for some time, and of course, it is a lengthy process. Often it takes more time than you initially expect to validate the solution or technology. Let me give you the example of our preventive maintenance solutions that we have integrated into the Volkswagen plant and car body. This is AI models that basically monitor the performance of certain assets in the car body line, like weld guns, as mentioned, or clamps. We look at them using the Siemens Edge technology, for example, and then AI model that will monitor these systems and analyze the small faults and the small delays, and then predict a health score and tell us, okay, is there a problem? And that is a good example for the scaling issue, because this is certainly a topic where you have a great potential to scale. We have hundreds of stations in a car body line. Each of the station has many clamps. So you have thousands of clamps, thousands of weld guns in a factory. In the world, there's a lot of factories. Volkswagen operates, I think, 100 or so factories, and there's many other. So this is basically, from the business side, a solution or a problem that sounds like you can scale it. But how do you really validate it? That's the first challenge. So we typically undergo validation as early as possible in our projects. We try to bring it into the shop floor or into a pilot, into a test cell maybe first, and then maybe to a selected environment when we can operate with low risk. And then we validate it for a certain time, obviously. Classical engineering approach, we get results, we improve. And then we enter the phase where we think, okay, it can work. we tweak and improve the solution, at the same time work on both a business and a technical model, how we can bring it into a wider audience in the company. And this would include selecting the technical components, like thinking about, is the Siemens Edge ecosystem something that we can use to scale? When will it be integrated? Where? How? How do we connect the edge devices to the data in the controls and in the line? And then we see, okay, maybe some areas are covered by an automation standard on which we can dock onto. Some areas maybe are not yet there. So these are the factors that we consider. And is there a magic recipe for it? I believe it's hard work. It's hard work to do that, to achieve it. It takes more time than expected, yes. Our approach is that we try to consider all these factors from the beginning. We try to involve the stakeholders, the IT, the operator environment, the innovation specialists, the AI specialists, the data specialists. We involve all of them as early as possible, and we try to keep them onboarded and involved during that process. And I think that is the road to be successful, because things change over the course of such a project and such a development. And you will always, as Florian mentioned earlier, you will always find some unexpected blocks that you think about, like accessing a certain control device, and you suddenly you cannot access the variables, or non-availability of certain components, or you don't have access to a certain line due to different reasons. So things like that can always delay you, and then you need to stay on the topic and keep working not to solve it.
But you need a commitment, right? You need a decision. Let's do it at the end. So you need a decision from the C-level. Then you need a decision from the operator. So the commitment for AI needs to be in all stages, or am I wrong?
Yes, that is true. So, and we are lucky we have it in most cases or many cases. So you're talking of Volkswagen, maybe it's known there's a strategy or commitment to go into the AI race or IT.
But you also need the commitment maybe to change processes. But this is difficult when it comes to, let's say, traditional machine building, automotive industry, to change processes. And how do you handle topics like this?
Yeah, with our main customer, we have a process for that, a specific one. They operate and we operate it together. It's called the technology development process, where we talk about the integration of new technologies or change of technologies in running manufacturing lines and production. And this is a process where you have to run several checks and ask yourself a lot of questions about how the future solution will actually work and run. It involves technical feasibility criteria. It involves IT-related criteria. It involves the question of who will provide maintenance and improvements later on. So the business side, of course, the financial aspects, it's all in there. And I mean, it's
a framework to do that.
It's a company framework, exactly. It's not a strict process, but it's a framework where you have to ask yourself questions, and you have to critically ask yourself them. And we do it together with our customer and with all people that are involved into providing and generating the solution. So the shop floor, the operator, the innovators that we work with, the innovation experts, the technology drivers, and also, of course, not only the senior, but also the middle management, the people that have to decide, are we ready to go? Are we really ready to go with that technology? Those that have the responsibility that even after you introduce a new technology module, the line will still work, right? In a running factory, you could introduce a new software or hardware module that costs only little money, only a few €1,000, and you could break the entire line. This is not what we want. We want to inject new technology and still everything needs to be running. This is a very different approach from thinking in the way of let's go and break things, right? So we do not want to break things. We want to improve things while having them running. And it's a little bit like operating on open heart, as we say in Germany, right? So the patient is already living. Actually, he is already walking and running, and we have to make improvements during that process.
Florian, last use case, last project.
Yeah, this generative deep learning I've already referenced. We talked about generating synthetic data. This actually, there we used generative AI, and it's really working well to do that. You have use cases for this computer vision systems, but it's always important that the introducing these computer vision systems has been done and that these are running, and then you can settle on that. You can do generation of synthetic data if it's necessary. Sometimes when you have quality assurance issues, you need this is wrong data or this is defect data, and this is hard to get because you have to wait for a long time, because it takes time until there really something better occurs in a good running process. So for that, you really need the synthetic data. This is something where, as I said, generative AI helps. And when it comes to then to scaling that, is maybe also then connecting this to what Daniel said is, from my point of view, you also need platforms within the company where you can bring it on and where you can make it easily accessible for everybody. And when you have that, this lowers and all the efforts you have to do in order to get a solution. And this, when you have then a good solution combining with easy accessibility, I think these are good starting points for scaling. But you should also not be too early with the technology, because when all the other processes haven't been realized yet, you will have a problem, or you might have a scaling problem. So yeah, that's this second use case I can think about.
I want to come back to the synthetic data stuff. Can you share in 3-4 sentences, how do you use Gen AI to produce synthetic data?
For example, when you come to computer vision systems, you need images, and you need images from surfaces, for example. And there you can use diffusion models and the normal techniques in order to generate these data. You have, of course, to gather some data which is already of bad data or defect data, but then you can enable the model to generate you the defect data. There's work, of course, going in that, but it's possible. I think the images are really good, and they help, as Daniel said, they help to train a computer vision system.
So guys, what is on your agenda for the next coming months when it comes to customer projects, Daniel?
Well, one of our focus points at the moment is, as I talked about quickly before, is really working or continuing our work in bringing preventive maintenance AI to car body operations at Volkswagen. We are strongly involved here with activities, and we are making success and progress there, but there's still some work to do, obviously. But we see this is a very, very interesting direction. In the first thought, you might think that preventive maintenance...
Oh, it's solved. Everybody thought predictive maintenance is solved, but still it is not. Yeah.
Exactly. You think it's solved, it's no problem. You can just talk to the vendors and see many solutions on the market. What we are doing is we are bringing it into reality, right? We bring it to a real factory to be operated on real lines. And this is, as I mentioned before, there is a lot of work after just generating the software or the AI solution itself, but integrating it into the real system. That's a direction we're working on very strongly, and this is where we have a good cooperation also with our shareholder and parent company Siemens with their edge and AI technologies. This is one strong direction we're going forward into. This is basically our work stream, industrial AI and digital twin in the factory. We have other work streams that we are covering too, like AI, digital twin in supply chain and logistics, and in circular value chains. That's the second direction we are exploring. Yeah, how can AI help us in logistics processes, making predictions? Been involved, for example, with the Catena X consortia in the past, a little bit explored things there. So that's using digital twins in combination with AI for this kind of purpose, I think is a very interesting direction as well. And what is continuing is, for us, in the shop floor operations, we've made some successful projects with chatbots and copilots on the shop floor, and we will continue this as well. So helping operators, maintenance personnel, and factory engineers to improve running lines and to understand quickly now issues with the machine, getting transparency about the machine data, reacting to issues, diagnosing them, making root cause analysis. We believe that, or I believe that, beyond just chatbots and copilots for this, the entire approach of agentic AI, it can help us here to make workflows fast and integrate, access more of the data that we have available on the shop floor. We have a lot of data hubs, tabs, silos, sources available in the running factory, but it's not always in the formats and in the accessibility that we need to employ AI on top of it. So it's a challenge how to make this data available and accessible to AI. And on the other hand, make it scalable across the shop floor, providing solutions that are easy to use, where the user says, hey, this is cool, this is nice, I want to have it, I'm actually using it. And then scaling it across the platforms that we find at Volkswagen-Siemens.
So I'm really surprised that I didn't hear the word agents in your agenda for the next months, Daniel.
I did. I said agentic AI will help us in this.
Okay.
Addressing of the data and providing functionalities.
Okay.
So it's definitely on the program. Yeah, obviously, it's a technology where we have to see how far will it carry us. Right now, we are in a certain
evaluation
hype cycle, as we know, and we have to evaluate it. There's some industrial setting. An agent has to observe certain restrictions. Maybe you don't want to make an agent that will make decisions totally autonomously and address any source of data. So this is something that you have to figure out. What kind of degree of autonomy do you give to the agent, and which parts of the workflow does it support, and where are its limits, and at which kind of technologies do you actually employ, right? So will it be like these clause systems, or will it be smaller agents? How does it actually work together and orchestrate? And another important question when you try to build this for industry is how do you scope these solutions? Do you have general purpose solutions or very specific ones? Is there functionalities where individual departments, groups, plans, and users can configure their solutions, or do you have more general all-service solutions? That's all part of the question discussion.
It was a pleasure, guys. Thanks a lot. I keep my fingers crossed for your agenda, for your agentic approach, but also for the predictive maintenance, because I think it's underestimated in the whole industrial setting in the moment, still underestimated. And it was a pleasure to talk to you. Thanks a lot, and all the best for you guys.
Thank you very much.
Thank you. It was a pleasure. Take care.